Wednesday afternoon. Finally, Christopher Allen. We've been DMing for years, and you've been saying, I'll come on the podcast when we actually have something to show. And it seems like we're here. We're sitting down with Christopher Allen and Wolf McNally from the Blockchain Commons. They're working on very important standardization of Bitcoin software, and I'm very excited for today's conversation. Thank you, gentlemen, for joining.
Thank you.
Thank you.
Well, again, like I was saying before we hit record here, I think what you guys are working on, the Blockchain Commons specifically, is very underappreciated in the space. We've talked about it in years past in episodes of this podcast, standardization of some parts of the Bitcoin code so that you have interoperability between different wallet softwares, hardware wallets, mobile wallets, desktop wallets, whatever it may be, so that Bitcoiners can just pick up tools and expect that they will work and be interoperable with other tools. You guys have been applying and trying to bring this to market at Blockchain Commons, and it revolves around what you guys describe as Gordian Principles. I guess that's where I'd like to start today, is the Gordian Principle model, what you're applying it to, and how it goes into the ethos of all the products that you guys are building.
Great. So yeah, my name's Chris.
Christopher, seems like you may have just...
Did it?
Oh, there it is. Muted you. You're good.
My name's Christopher Allen, and I've been doing open infrastructure for a very long time. I'm the co-author of the TLS 1.0 standard, which of course now is the world's dominant security protocol. I did that in the 90s, and trillions of dollars of commerce are using it. So this is an area that I'm passionate about, and with my entree into Bitcoin 5 years ago, this has very much, been on my mind of how do we create a strong foundation for all of this that can last for, decades or even centuries. So I've taken a lot of, what and how things like TLS evolved, the community, the ecosystem, some of the best practices there, and the best practices from Bitcoin. I was a principal architect at Blockstream. I've been involved with a number of different projects in the early days of Bitcoin. But I really felt like there was the whole foundation was underserved, especially in the area of interoperability. So we started working on that, 2.5, 3 years ago, seriously, with different aspects of things. In particular, have been these Gordian projects. So as many people know, Bitcoin has been going through a lot of transitions right now with Taproot Schnorr and descriptors and multisig and all of that. But we're also carrying with us a legacy of old styles, old designs of how these things work. So how should the new ones work? How can they take advantage of these new technologies? So, we've really been focusing on these new Bitcoin architectures, and what does it mean to have a secure foundation for the ecosystem as a whole. So in doing that, we created something we call the Gordian Principles. The independence, privacy, resilience, and openness is really what we're talking about. Now, they all have deep underlying things. Independence, is everything from supporting user freedom, but also is kind of involuntary oversight, whether or not that's, censorship resistance or some kind of coercion or whatever, but also kind of the economic coercion that can happen in marketplaces and things of that nature. How do we prevent that? Privacy. There are other forms of coercion that happen because of strong identities and such. So how can we enhance privacy and pseudonymity? So we have a variety of different projects associated with that. Resilience is an interesting one. We definitely, security has this paradoxical property of making you maybe not less prone to certain kinds of attacks, but it also lowers your resilience and makes you more fragile to other kinds of problems. So how do you balance those? Because you really want resilience in both. So a lot of our work, for instance, the Smart Custody book that we came out with 2 years ago, and these projects are to try to cover this very interesting challenge of how do we decrease the likelihood of loss in general for regular people. Um, and then finally, openness. Infrastructure, open infrastructure means that we really have to have some common things so that if any of us fail, move on, etc., that we don't have, an ecosystem problem where some major party loses hundreds of millions or even $1 billion because of mistakes, and that'll affect us all. So we have to have a strong foundation, but we also need to avoid things like heartbleeds. So one of the things that was really sad for me is, a dozen years after I finished SSL 1 and TLS 1, and we were now moving on to 1.1 and whatever, uh, TLS became boring. We had one person supporting the number one open source project 1/4 time. Um, and trillions of dollars of commerce were being used for it. And a little bug creeped in, and some people discovered it and shared it. And, it was, probably actively used to steal keys and certificates and other different types of things for at least 6 months, if not longer, before somebody discovered it. I don't want to see that happen in the Bitcoin ecosystem where it's a lot more dangerous. So how do we support things for 15 years, 20 years, 50 years? That is, going to be best served not just by open source, but also open development and open infrastructure, which is a little bit more than just open source. So those are the 4 principles. When we look at any of our different tools, open source projects, etc., we've attempted to say, hey, this is what we do in independence. This is what this particular tool offers as privacy. This is what this tool offers in resilience. This is what this tool offers in openness, and share that with others. And we're hoping that it's not just us, because we'll talk about that later, about being a product company versus being a Schnelling point for the ecosystem. But we're trying to encourage others to do the same.
Yeah, and I mean, you brought it up. You mentioned it, especially with these open source protocols, more specifically this distributed system in Bitcoin. How do you create a acceptable, and I don't even know if acceptable is the right word, but a trade-off between security and usability that people are happy with and will bring more individuals who are not as tech savvy as your average early day Bitcoiner are to the Bitcoin protocol. And so I guess another thing you mentioned there, not directly, but I think what you're trying to do with these standardizations that lead to interoperability is avoid potential tech debt that could be built up around Bitcoin development, particularly as it pertains to wallet software.
Exactly. And that's, an interesting challenge, because sometimes, uh, early decisions are made. So, I mean, Electrum, one of the first, solid wallets outside of Bitcoin Core, made some decisions that they, have to continue to support because they have a set of legacy users, which then makes it complicated for everybody else who wants to, interoperate with them in the future, or forces some architecture changes, or sometimes what I call invisible architectures that can cause long-term problems. So we have to address, there's this interesting problem with open infrastructure is, how do you retire it? How do you replace the important bits and not leave people behind? It's hard, especially again, I'm trying to think in the terms of decades.
Yeah, decades, maybe centuries, who knows? And it's crazy to think of this early on in Bitcoin's history of the project, 13 years in. Even though we're 13 years in, the decisions we make today are going to impact people decades from now. Do you think there's enough weight on people? I don't want to say consciousness, but do you think people understand the gravity of the decisions that are being made today to the Bitcoin network that will affect people in the future? Or you think
I
that's
think we're doing an okay job at that at the Bitcoin consensus layer. I am one of the reasons why I am such a big supporter of Bitcoin is, how the Bitcoin developers and adjacent developers like Lightning, et cetera, are thinking about security and how they're thinking about these types of things. But that being said, Bitcoin Core is not a good wallet. Um, so when we start, talking about the broader implications of Bitcoin, the broader ecosystem, that's where it gets complicated. And we have centralities, or at least, almost duopolies up until fairly recently. Um, we have to address that.
yes? And in your opinion, what is the best way to address this? So let's get into like the Gordian suite. Where are you trying to create standards specifically? Obviously, you have things around like how you produce seeds, how you secure those seeds, QR codes, something as simple as what some people would think is simple in a QR code. One recent problem I ran into was trying to recover a wallet using a seed phrase on a particular software that wasn't familiar with the derivation path that I produced the private key with, and so there was an issue there, and like
Yeah.
these pain points.
But yeah, and those pain points are going to get worse. I think one of the lovely innovations in Bitcoin is how it handles keys, which basically is it throws them away. But early Bitcoin software basically just, it randomly created every single individual key separately, and then it had a key management problem of lots and lots of keys and all of that. So BIP39 was invented to allow you to create these lists of keys that had great security properties. That being said, they weren't designed with multi-sig in mind. They weren't designed with various kinds of future proofing in mind. Last time I looked, there were over 40 variations of single sig derivation paths in Bitcoin between different kinds of ways of doing accounts. BIP 45 versus 74 versus legacy Electrum, how change is handled, gap limits, etc.
Gap
And that's
limits.
a real challenge. And it's gotten worse with multisig. So if we are really focused on descriptor-based wallets that use multisig, and I'm very actively trying to encourage some parties to delete their single sig capability from their wallets. And if they're a tier 3 new wallet company, do they really need to support legacy? I'm not sure they do. And I've got some good designs for a 2 of 3 that we would love to see some wallet companies do that for self-sovereign wallets. Multi-sig does not necessarily mean multiple people. But anyhow, back to the key issue. Um, there is state now that needs to be kept. What we call an account map. It's called different names by the community, but it's basically the multi-sig descriptor at minimum now also needs to be saved. Now, fortunately, it's public keys that are in there, but then that can potentially violate your privacy. Other interesting problems, this is not one that I have a great solution for, is multisigs all largely are using the 48 derivation for the single key, which means the XPub that you share, say, with CASA for some account, multisig account with somebody, and the XPub using that same Trezor ledger or whatever that you're using with, say, Unchained Capital, is exactly the same XPub, which gives them potentially an opportunity to, go, oh, what other accounts are out there that this person uses? Now, they need more information. It's not super easy, but it is a weakness that we're reusing XPubs even for privacy. So, these are all the kinds of things that we're trying to identify at Blockchain Commons and see if we can, have some low-hanging fruit to address them, or at least raise the issue enough to the community to kind of go, is there an emerging consensus that this needs to be solved? And so in that particular case, after talking with a lot of wallet developers and things of that nature, they're kind of like, yeah, we don't like it, but it's not critical right now compared to other problems. And that's fine. So we're not putting a lot of energy into solving it.
Interesting. Wolf, would you have anything to add to that? Things we should be
Why don't you
aware of?
introduce yourself a little bit first, too?
Yeah, sure. I'm Wolf McNally. Christopher and I met, I don't know, maybe 15 years ago now. Christopher ran a series of iPhone/iOS developer camps in Silicon Valley, and I lived in Los Angeles at the time and attended several of those. And Christopher and I got to know each other and became friends. And when he started up this project, it was a good confluence of events. It turns out I was available to work with him, and I guess I've become kind of a Blockchain Commons de facto lead researcher. So that basically involves, working with Christopher to identify the issues that wallet and blockchain developers are having, and then figure out, what we can best apply our talents to, and then basically producing research papers and reference implementations. And that the reference implementations can take the form of libraries that you can link to, or command line tools that you can run, or apps. And I've been an iOS developer, as mentioned, for many years. So basically, I've been kind of capturing these ideas that we've identified problems, and then produced a series of research papers. And you can check out our GitHub account where we have all of our research papers listed. Everything we do is open source. So, from our command line tools like Seed Tool, which has a similar functionality to the Seed Tool app I'll be showing you, which is a command line tool, and Key Tool, which derives keys and things like that. Also command line. To the various apps we've done. I've been heavily involved with most of those, although there have been several other major contributors as well who've contributed other major apps or pieces of software to Blockchain Commons. And so that's a little bit about me.
Awesome. And so I guess you guys are talking to a lot of wallet developers, and you're trying to build or at least build tools to show, hey, this is the way you should do things and adopt this type of standard. What are the number one things that are coming top of mind to wallet developers? Like, because there's this weird thing too, where you have especially with the hardware wallets, you have the individual players who have a profitable business in the hardware side, and one could argue there is an incentive to create a moat so that more people use their wallet. How do you take that into consideration and then try to work within pain points on the software side as well?
I mean, I think our biggest ecosystem success has been our UR standards, in particular around PSBT. So PSBT is an incredibly useful format for having a partially signed transaction and or a completely unsigned but assembled ready for other wallets to review and basically go, yes, I'm willing to participate in this and continue. I'll sign my part and pass it on. Well, it turns out there are a lot of gotchas because PSBTs need to be moved from one place to another. And there's information that may be associated with PSBTs but aren't actually in the PSBT itself. We have different kinds of wallets with different form factors. some people are fine with a USB, or even worse, a USB-C cable between their hardware device and a computer. Others are going, no, we don't want to do that. And so they're at least trying to air gap it through little Java cards, SD cards that have a Java capability, and then of course, the nirvana we're really kind of going for is true air gaps. Let's not even have the devices communicate electronically directly. That's not to say that QRs are perfect, but they have some clear advantages. And then we run into this problem of, gosh, PSBTs can get to be really big. How do we deal with that? And we found some very nice sweet spots with some interesting design challenges along the way, which Wolf can talk about. That now there's half a dozen wallets that are supporting our bare PSBT, and we now have two services, Casa and Unchained Capital, that are doing it for transaction coordination, where they don't have any of your keys at all. So so this is probably our biggest success. Still a lot more to do. It's still a pain to save keys. There are definitely issues with state, not just the account maps, and descriptors that you might need to have, but Lightning has some interesting problems with channels and storing that information and other stuff that we have made some progress on, but we're looking for more wallet developers to join the community so we can solve it together.
Yeah, it's PSBTs are a fascinating part of Bitcoin, and they're almost magical when you send a PSBT for the first time. I usually I've done it with Cold Card, with the air gapped way, where you never were technically air gapped, I guess, if you never touches the internet, but you construct the transaction on the device, move the SD card to the computer, or you construct it there, move it back, sign it, then broadcast it from the computer. It is an involved process, and you mentioned QR codes are here to help, and they're harder in some ways, but a lot easier in others. How do QR codes fit into all this, particularly around the communication of the data size of the PSBT?
This, I think, would be a great segue to Wolf to demonstrate it can be even easier, and we even have some new things that are emerging that make it even easier than what we're going to show you just now. But let's talk about one of the easiest integrations, which is Sparrow Wallet and Seed Tool.
Sure. Yeah. So we basically, as my conversations with Christopher have gone on, we've identified kind of pain points in the developer community. And so then I've basically gone off and done the research, written proposals. We've kind of gotten them reviewed by various people, and then I've implemented the actual code for those. One of the most successful ones has been what we call our uniform resource, or UR proposal. You've heard of URLs, uniform resource locators. They point to things on the internet. Our UR proposed standard is, a number of people have adopted it now, so it's a de facto standard in some ways. Is a self-contained resource. So it's an actual string of letters, like a URL. It begins with UR colon, just like URLs begin with URL colon, or HTTP colon, a scheme. So there's a scheme of UR colon, and then it includes data. So it's completely self-contained, and it's designed specifically to be efficient when transmitted as QR codes. But QR codes have an inherent limitation of about 4,000 bytes of data in one code, and that's even pushing it because that's really dense. And screens, obviously smaller screens like on a hardware device might have trouble showing such a dense QR code. Cameras, especially like webcams and so on, might have a hard time reading such a dense QR code. So you can't really even approach that 4,000 character limit. But partially signed Bitcoin transactions, or PSBTs, can be much greater than that, because the signed transaction itself
bytes, because it might have a very number of UTXOs in it. Each of those UTXOs,
I think you just switched microphones. I think your head's...
Right?
Yes, we can hear you. Okay.
Hello?
It can hear you.
I don't think he can hear
Can
us.
you hear me?
He can't hear us.
Yes, we can hear you, but you can't hear us.
I'm hearing, I think you're hearing me, but I'm not hearing you. Let me try to reset my audio here. Sorry.
That's correct.
I was on a roll there too.
Can you hear me now?
Yes, sir.
Yes.
Good. Sorry about
Can you hear us?
Yeah. So
there we go.
yeah. Partially signed Bitcoin transactions can have a lot of UTXOs in them. That adds, and then the signatures themselves add more and more to the size of PSBT. You rapidly outgrow a practical size for a QR code. So we realized that our way of transferring these things through an air gap between a QR code and a camera needed to be able to provide, like, say, a series of QR codes with the message broken up into fragments. But that has a problem too, which is that, if you just show a chunk of the data, you have to identify what's in the data. You have to identify, and if you miss fragments, because QR codes aren't always read properly, then and you show them the same QR codes over and over again, you get to the point of diminishing returns where you're missing that one QR code, but you keep missing it. So we needed a better solution for that. So and there's another parallel issue, which is that we want our standard to be able to support all kinds of structured data, not just PSBTs, for instance. You can put the raw bytes of a PSBT in a QR code. Sure, you can break them into fragments, sure, but we want to be able to have all kinds of data, like requests and responses, so that one device can request a PSBT of a certain kind, and the other device can provide that. So we want to be able to have kind of a networking between devices with air gaps using requests and responses. So we need ways of storing structured data. So the UR standard supports all of that and supports kind of one of the most highly efficient ways of encoding things in QR codes. And so you can actually, all the details are on both our GitHub site, where you can actually read the papers. Our YouTube channel also has a high-level technical overview of a lot of the technologies, including the ones I've been talking about. But the long and short of it is you can stuff any amount of data you want into a UR, and it will get broken up into an animated QR code using what's called fountain codes, which are a way of avoiding that whole miss that one QR code over and over again, because it kind of mixes the data between the whole block of data into each QR code. And it actually makes it, interestingly, more and more likely you'll get all the data you need to finish the message as you keep reading QR codes. And again, we have demos of this on the command line. We have test vectors, the people who write it. And we actually had, I think we have 6 or 7 various implementations of the UR library, Swift, Python. I think somebody's done a Rust implementation, the C, C++, and so on. So all these are available for developers to start using today. We've been developing a number of these technologies. Another issue that we identified was that you needed to be able to identify binary objects at a glance. Now, humans are not very good, at identifying binary objects at a glance. A couple bits could be off and you won't notice. So we needed ways of rapidly doing that. Now, you might have seen like emoticons, which are basically these little icons that get generated. I think you see them on Reddit and some other places where, your default account, unless you change your avatar, has this little funny icon, and it's yours. Nobody else has one quite like it. We came up with a rather innovative way of doing that called LifeHash, and you can go to lifehash.info and see a live demo of that running in your browser using WebAssembly. So this is also another thing that's totally open sourced. And basically what we use it for is to identify things like seeds, keys, and other kinds of binary object. And we'll talk more about seeds in a moment. Another issue is that, like Christopher was saying, 39 standard HD keys, hierarchical deterministic keys, let you derive a whole bunch of keys from one master key. But we realized that there's actually a step before that, which is you have to generate the entropy for the master key. So the entropy is random numbers. And that entropy itself is useful. And so if you take it back one more step, you get what we call a seed. And a seed is just cryptographically strong random numbers of some length, like at least 128 bits. From that, you can derive master keys. You can derive from that, you can derive account keys. From that, you can derive address keys. And so there's a whole kind of chain of derivation that can happen that starts with seeds. And so what we wanted is a way of managing seeds in kind of a very general way. And so we came up with SeedTool, which is both a command line tool, which lets you derive seeds, ingest them, and transform them. And then also our iPhone app, which you can actually get in the iPhone App Store today. And you can also download the source code, compile it yourself, check it out if you're a developer, and that's what I'm going to demo. So we're trying to show, and Seed Tools turns out to be a good showcase of a lot of the technologies that we've been developing, including the animated QR codes, including another one called SSKR, which is a way of splitting your seed up into a number of shares, which you can hand out to people and have kind of a social key recovery system. Christopher can talk a little bit more about that. And basically let you spread out that data. So if you ever lose it, you can recover it. Like say, you might have 3 groups of friends: one for your professional associates, one for your personal your friends, and one for your family. And you can give out these 9 shares, and you only have to get back 2 from 2 of those groups to actually recover your whole seed. Whereas none of the people have enough in those groups, even if they collude to recover your seed. So SSKR is that technology, and that integrates with the UR stuff, and that's integrated into Seed Tools. So, Seed Tools is kind of like, a great showcase of a lot of the stuff we've been working on.
Sounds like a Swiss Army knife.
Yeah, in a sense, yeah. I mean, it's got one major goal, which is to manage your seeds in a secure way, and to let you purpose them for various reasons, to derive keys from them, to respond to requests for seeds or derive keys, things like that, to back up your seeds, to restore seeds, things like that. So Seed Tools is all about seeds, and it's intended to interoperate with other hardware wallets or software wallets like Sparrow Wallet, which I'll be showing how to set up an account using Seed Tool managing the seeds, and Sparrow Wallet actually managing the account. I'd say it's a Swiss Army knife in the sense that it shows off a lot of the cool things we've been developing.
And one thing before we hop into the demo, just to make it clear to anybody listening at home or watching as well, how would you describe the importance of entropy, and how do you create entropy in Seed Tool? Because people don't realize this. They'll just get a device that can spin up a private public key without editing entropy. And
you want me to talk to that, Christopher?
Go ahead.
Yeah. So, random numbers aren't, there's a very funny Dilbert, which basically, they're showing around the office, and they're showing Dilbert to a desk, and there's this monster sitting there saying 1, 1, or no, 9, 9, 9, 9, 9, 9. And the guy says, this is a random number generator. And Dilbert says, well, how do you know they're really random? And he says, well, you can never tell. So the idea of creating quality random numbers is actually really hard. Most computers use what they call pseudo-random number generators, which use a seed number you get from somewhere and then generate a very deterministic sequence of numbers. So, and many pseudo-random number generators have been shown to have both statistical flaws as well as ways that you can manipulate the entropy that goes into them that make them unreliable or hackable. So cryptographically strong random number generators are used by every wallet to create your key, because you need a random number to create your private key from which you get your public key. But some people are suspicious of that too, and so they want to actually take control of the randomness themselves. If you want to create a truly random key, then you kind of got to do it yourself if you want to have ultimate confidence in that. So some people choose to flip coins or roll dice or draw numbers from well-shuffled packs of, draw cards from well-shuffled packs of cards. And those are actually provably, truly random. And so if you generate that entropy yourself, then you can generate the seed from that entropy, and Seed Tool supports that as well. So you can actually start with, you can either tell it to use the built-in cryptographically strong random number generator to just poof create you a seed, or you can say, nope, I want to provide the entropy myself. And you can show that, the same entropy provides the same seed. So, but you generally throw away the entropy, keep the seed, and then derive all your keys from that. But if you generate the entropy yourself, you can have confidence that nobody tampered with it.
Also, another, challenge here is that, especially with hardware keys and things of that nature, are you really sure that it's a random number? Or that they've done the derivations right to create the seed that you're using, that there isn't some gamesmanship that happens between the pseudo-random number, other entropy that's added in and whatever, ultimately to your to the seed that you have. So if you're really wanting to be super careful, I'm not saying the average Joe ought to needs to do this, but you can roll dice, and there's some good techniques out there to get everything except the last word in a seed phrase, and show that maybe on another device. So this is this is LethiKit, which uses yet another version of Seed Tool, where you can just put in the dice numbers by typing them into this keyboard, and the result should be at the end the same exact seed as generated by the command line version, where you can look at the code and see, as well as the version that's on your iPhone. So if all three of those versions plus the hand version, all given the same dice, give exactly the same seed, then you have some confidence that no games are being played at the lower levels, and that's good. And I wouldn't necessarily you do all four of these and then use that dice, but it would give me some confidence that now I can roll dice one last time and have the entropy that I want.
And one of the cool things about LethiKit is you build it with off-the-shelf parts. The case is 3D printed, and you can it uses Arduino, so you can review the code yourself. You flash it, and you can have total confidence that you're basically controlling everything about that, and it has no storage. So when you turn it off, it forgets. It has those little e-paper screen, which doesn't blank because it just remembers forever, but nothing is secure on that screen once you go back to the home screen. So it has no long-term storage, and then definitely no network connection. So everything you do on it, including rolling your dice, putting your number in, deriving your key, and so on, never leaves the LethiKit device. So that's a pretty cool thing about that.
It's really cool.
I should also say Seed Tool is designed, even though it's an iPhone app, you can run it on your regular connected iPhone, or you can go out and get a little iPod Touch. You can install Seed Tool on it, then turn off the network, and then it remains forever then a network non-connected device. You can put it in your safe, keep your seeds in it, back up your seeds using SSKR among your friends and family, and have a lot of confidence that even if something happened to that iPod Touch that you might use to sign high-value transactions using your seed, you basically you're covered any number of ways.
That's incredible. Being able to use other hardware to basically just store the software. I mean, let's get into a demo for anybody watching at home.
Yeah.
Wolf has a demo lined up for us just to go through how this works, and then we can take...
Yeah. So I've got the Blockchain Commons research website up here, and I just wanted to kind of scroll through this. These are the research papers we've done. A lot of them have my name on them. There's a few people who've been collaborating with us as well. LethiKit and Gordian Server and so on were created by other guys, and I've been working with them. But basically, this is all open and available for people to look at and use, and that's github.com/blockchaincommons/research. And so the specs for URs and so on are all there. Let me add away. So I've got my iPhone up here, and that's the first thing we'll look at. So let me put that front and center here. I'm going to start with Seed Tool, and right now I'm actually down into a separate page here. So basically, Seed Tool gives you a list of seeds. You may never use more than 2 or 3 seeds, but I've got a bunch of seeds I used to test with here. And each seed, you notice that image, that colored image to the left of each seed, that is a life hash. And so, again, if you go to lifehash.info, you'll see more information about the algorithm that's used to create those. It creates kind of organic-looking patterns that are very distinct. So even if you change one little bit of the input, the entire image changes. And they're also quite memorable. When you drill down into one of these seeds, this is one of our test vector seeds, you see more detail about it. And one of the things you see, in addition to the life hash, is to the right of it, you see the little seed icon that says what this is. This is a seed. You see that little sequence of hex numbers up there, and that's in a way, for example, Christopher and I earlier, he transmitted this to me, and he said, is it F0B0B2C? I said yes, rather than having to say, is it that purple thing that looks like a doily? So it's more precise, and then you can of course give your own name to it. Scrolling down, you can see other things about this seed that aren't sensitive, like its name, its creation date, any notes. And then there's this yellow button called Authenticate, and this is basically where you access the seed itself and do other things with the derivations, because seeds themselves are sensitive. You use them to derive private keys and public and private, addresses from those. If I tap Authenticate, then it's going to ask for Face ID. So, and that basically, obviously means I'm the authorized user of this phone. And then there's several different options. You can back up your seed. So there's a couple different ways of doing that. You can back it up as SSK or multi-share, or you can back it up as a UR:crypto seed. Now, remember I mentioned that the UR thing lets you put data into a string of characters that's designed to be displayed in a QR code, or ultimately or even if it's too long, broken up into multiple QR codes. So let's just say I want to back it up as UR::crypto seed. So you see that QR code. That can be scanned by anybody who has Seed Tool or another tool that can read our URs. If this were too long, that QR code would automatically be animating, and I'll show you an example of that in a little bit. But you can also print it. You can say print that, and then you get an actual printout that not only has the QR code, but also has the actual hex value of the seeds, byte words, and BIP32 words. Byte words are another technology we developed that gives you 4-letter English words that represent 1 byte per word. So that's another way of kind of creating a mnemonic. And then the other metadata about the seed. So you can print that to your printer. You can also say share as UR::crypto seed. And you see that this one, I can basically copy this to the clipboard or whatever. But you see that where it says UR::crypto seed, that's the actual text that would appear in the QR code. So that's one example of kind of a stack of our technology being used to do something. Another would be if I tap back up and say backup as SSK or multi.
Oh, we lost.
I think we lost
your mic.
Your connection again. Wolf's going to be getting that back. This is fascinating.
So yeah, I'll say a little bit. While he's coming back. I showed you Lethe Kit. So one of the big challenges for, we want to serve the whole community. This is a little tiny 200 by 200 display. So when we designed QR, we wanted it to be able to do animated QRs on this very slow processor with this very slow screen. That only has 200, by 200 black and white things. It works. And yeah, it takes a little bit longer, but it's, you can do some, I think we did like 100,000 character PSBT with it, and it worked. Similarly, Wolf worked really hard to make sure that the life hashes, which help you recognize things. So I, obviously printed this on a regular piece of paper. So there's no color there, but it's recognizably the same thing as the purple one. So even though I don't even have necessarily the same display, it has a design for high contrast that lets you do things. And we also don't want to lock people in, so we support, all of the, good old-fashioned BIP39 but sometimes the dates are really useful to know when it was created, and the notes come along with it as well. So I can say, hey, this was only used with some obscure wallet that I, don't use anymore, but I'm keeping it because it's got some dust on it. Because I know I have some dust from when Bitcoin was, $30, that all of a sudden, I came back to an old wallet and it's saying, gosh, I've got $500 there. You can save all those. Let's see if Wolf's microphone's back. Nope.
Can't hear you, Wolf.
Nope. No wallet. Nope. Okay. So, I want to. What time did you want to run till?
I've got plenty of time on this end. But one thing.
Okay.
I mean.
Sure. So we'll let him work on that for a moment. So you can kind of see what we're trying to do in general, and in many ways, this is evolving as we go along. So one of the challenges with PSVTs, I know you ran into this with Cold Card, is how do I coordinate between the transaction coordinator on your computer, which because it has to have all the inputs for your transaction, and the only way it can get it is from the net, and then you have to, get that onto your phone or onto your device in the case of a Cold Card. Um, but when you start talking about multi-sig and descriptor wallets, well, that means you might need to get a key, an XPub from Casa. You might need to get another XPub from your Trezor, and you want another XPub from your wife.
Can you hear me now?
Now we can. So that becomes a challenge.
Okay.
So our emerging stuff lets you make that part, the whole setup before the PSBT happens, a lot easier. So we'll show crypto account in a second. So go ahead.
Yeah. So I apologize for that. If this keeps happening, I'll switch. I switched to a different microphone actually. So hopefully this one will not cut out on me. So we were talking about SSKR and the actual, as I mentioned before, SSKR breaks up your seed or whatever data you want into chunks that can be distributed to various people. And so you can say there's, if I have, 5 people and I want to share that among 5 people, then I can say, okay, 3 of 5. And you can see, I have one group of 5 shares with a threshold of 3. That means any 3 of these 5 shares can reconstruct the key. So let's assume that's what I want to do. I say next. And then basically you can either print the shares, you can share them all as byte words, or you can share them as UR crypto SSKR. That's another kind of UR. Again, URs can be used for any kind of data. And so, for example, if I wanted to print them, then I get these coupons that basically each have a QR code on them. They have some byte words, but they don't have the actual seed. They just have a chunk of the seed, a share of the seed. There's actually 2 pages here because there's 5 shares and there's 4 per page. So I can cut them up and I can actually physically hand them to other people. And then when I get back 3 of these from anybody I've given them to, then I can use Seed Tool to reconstruct them. And so but I'm going to move forward in terms of demonstrating. So Seed Tool has a scan function that lets you scan individual seeds or SSKRs or requests for seeds or derived keys. There's actually a lot there. So let's go back to the main seed, and let's say I want to use Sparrow Wallet to have an account, but Sparrow Wallet is connected to the internet, and Sparrow Wallet is on my computer that's connected to the internet. It's possibly has security vulnerabilities, whatever. I want to keep my seeds from which my private keys are derived absolutely offline. And so let's say I have an iPod Touch. My iPhone will stand in for that right now, where I have my seeds. And let's say I'm going to use this with one. The dark purple aqua love seed, which again is just it's a sequence of random numbers, but it's a unique sequence that I've generated. And so I'm going to tell it I want to authenticate, and then I'm going to say derive a key. Now I can either derive a cosigner private key, which is again a standard from Blockchain Commons of how to do multi-sig cosigners, but I'm going to go to the other key derivations in this case, and this is a fairly involved page here, but it's a workflow. It starts with the seed at the top. You give it a certain amount of parameters, and then you can see there's the private HD key that's been generated. There's the public HD key, and below that, an address. And so you can just use that address and receive it there. But you can say whether you want this asset to be a Bitcoin address or an Ethereum address. If you do it in Ethereum, then you can see it's switched over to Ethereum's style of identifying accounts or private keys. But let's say I want it Bitcoin mainnet, and you can derive cosigner paths or SegWit paths, or you can enter your own custom paths. So I'm going to keep it on master key, and I'm going to go down here where it says secondary derivation. Now I can either generate the public key, which you see is what's below the public HD key, or I can set it for an output descriptor. The Bitcoin output descriptors are a way of describing a range of ways to derive other public keys. Or there's the account descriptor, which is a whole bundle of output descriptors. And so an account descriptor, in this case, you give it an account number, and then the last step below is that says, here's your account descriptor. And it's a long UR. So in this case, I'm going to show it as a QR code. And you can see that it's now an animating QR code. This is a longer QR code that's been broken up into chunks. It contains a bundle of output descriptors. And this is something that that other wallet developers can write code using our open source implementations to read. So I'm going to use Sparrow Wallet here. Sparrow Wallet, developed by Craig Raw, is one of the first to support our technologies. So I've got no accounts right now. So I'm going to tell it I want to create a new wallet, and I'm going to call it Blockchain Commons. I'm going to create that wallet, and now it's going to say that it currently doesn't have an actual key. It needs a public key, because remember, the public key is going to be on my laptop. There's going to be no private keys on my laptop. So I'm going to say I want to connect an air-gapped hardware wallet. And now Sparrow supports a number of different ones. And if this were in light mode, then you should see our logo better, but C-Tool is one of them. And I just put it in dark mode before the podcast, and now I should suggest to Craig that he should make these stand out better. So anyway, Sparrow Wallet helpfully gives you details about how to derive these. Now I just did this on C-Tool. You can still see it's animating back there. And like I said, this is a fountain code. I can actually pick up anywhere within the sequence, and you can dip into the fountain and pick up from the stream and read the whole thing. So I'm going to say I want to scan it. And let's see here. Okay, so this is using my webcam. So I'm going to hold this up so I can get it aligned here.
Yeah, there we go.
Yeah, other left. Right, it's backwards. There. You see that progress bar?
Mm-hmm.
So it read several of the QR codes starting anywhere, and now, as you can see, it has an XPub here. And that was derived from the seed, and it picked which one it wanted. It wanted a witness public key hash coming from seed tool. And so this is how it derived that key and how the wallet's to use that key. So now when I say apply, I can just have no password on this one. Now, basically, I have an account. Here's the transactions. Now, if there were any actual transactions on this, it would go out. Sparrow Wallet, because it's connected to the internet, would go out and do them. Now, when since I don't have any transactions on this, I'm not going to carry through and do a PSBT. But then what you do is you would construct a partially signed Bitcoin transaction from the balances from the UTXOs on this account. Then you would transmit a PSBT back to seed tool that would then recognize, oh, it's asking for the seed that I already have. So I'm going to sign that PSBT and send back the signed PSBT back to Sparrow Wallet. And then Sparrow Wallet can put that onto the network. There's basically kind of a conversation between your online hot wallet, which only has public keys, and seed tool, which only has the seeds and can derive private keys on demand, but does so in a highly secure way.
Would Sparrow even be a hot wallet in this case, or would it be a watch-only wallet?
This is a watch-only.
Yeah.
Yeah, it'd be considered a watch-only wallet.
Yeah. So it's
but again, there are different scenarios. I mean, part of what we're trying to figure, we are with smart custody and some of our efforts trying to make it easier for people to consider, what is the right scenarios for things. So you could have one key on your Mac, one key on your phone, and one key in an SSKR among your friends in a 2 of 3 multisig. So that means that there's no single points of failure. Your Mac could die, you lose your iCloud account or whatever. Well, you can go to your friends and your phone and still recover it. You're not all 9 of your friends abandon you. You can still recover. Your iPhone can die. You can still recover. So that's back to those Gordian principles of resilience. But the workflow is exactly the same. I need to give you an XPub, and there are also shortcuts. So like this is a special shortcut. So if you use seed tool, oops, where's the camera? If you use seed tool with this is a request that says, please give me an XPub. And if if Wolf scanned that, it would basically say, hey, somebody's asking for an XPub. Do you want to give them an XPub? And if you do, which seed do you want to give it? And you choose, and it will streamline the whole process of setting up the accounts and all that kind of stuff. So that's
and then
the
when you
next
later on you receive a PSBT to be signed, it says, oh yes, I have the seed. Do you want me to sign the UTXOs of this PSBT that I know how to sign? So it's entirely within the user's control.
Yeah, and it seems like a much better user experience, particularly with the QR codes, because now I'm thinking, like, I just spun up a BTC Pay server and took an XPub from a hardware wallet and copy pasted it into the BTC Pay server interface, where now what you just described and what you just demoed, Wolf, would be much easier if BTC Pay server is just like, let me scan a QR code. I just held up an XPub from
exactly,
and that's
and it gets even
that's more
like
secure too, right?
Switching BTC Pay to a multi-sig. I want this year's donations to Blockchain Commons on BTC Pay to go to a multi-sig account that has greater resilience and single points of failure, et cetera. And it's kind of hard to set up a multi-sig with BTC Pay. I mean, it's doable. But all I would have to do with the QR thing is it would basically say, here's what I need to do a multi-sig. And, it would present the first QR code in a request, and it would go through the different things. And I would do my different wallets. I'd do my foundation devices, and I'd do my, Sparrow or Blue wallet, or, whatever else out there is there for my multi-sigs. And then at some point, BTC Pay says, hey, I have everything I need. I'm ready to start being your invoices because I have all the XPubs I need.
Yeah, it's crazy. Again, like I said in the beginning of the episode, before we started recording, I mean, what you guys are building is very much underappreciated in the space right now. I don't think people, particularly I don't call them laymen, but your non-technical Bitcoiner who's just a casual listener, probably doesn't understand how important these types of tools are.
Well, obviously, we're working with primarily wallet developers and people who are working more core towards Bitcoin technologies, but we want this to trickle down to all the end users. Right now, like I say, if you're using Sparrow Wallet today, you can use Seed Tool to keep your seeds, and Sparrow Wallet doesn't have to manage anything private. So, but there's no reason why people can't create seed managers, cold wallets, things like that use all of our technologies to do the same thing. And even and add their own secret sauce. So because everything we're doing is open source, and we're hoping that wallet developers and so on will see that what we're doing is valuable and support the Blockchain Commons, because we're a nonprofit and we're basically trying to create a better world together. And there's still plenty of room to compete.
Well, number one, thank you for building all this and doing it the right way. And number two, I think, like we said earlier, again, like, we need to avoid as much potential tech debt as possible. So getting as many wallet providers or wallet software developers on these standards as quickly as possible is just going to make scaling much easier and make loss of Bitcoin, or like the thought, because that's a lot of people think they lose Bitcoin, but they just don't understand that they're interacting with the wallet software. It doesn't know how to find their derivation path. They probably haven't lost it. Yep. They just can't find the derivation path where it's hidden.
Yeah. And we are trying to work on those two things. The project that Wolf has been working on this week is called Gordian Recovery, which specifically is designed to go through the 40 plus different common paths and gap limits and things of that nature to see, gosh, is there anything out there for you? And again, since we're an ecosystem organization, I don't want to compete with Sparrow or any of the others. But if we can create kind of a universal process of discovery to allow you to recover, that's useful for the whole ecosystem. And then you can recover it with your foundation devices, or you can recover it with any of the other people that are supporting the standards. And we think that's important. And then we need to carry this to Lightning. Lightning has some additional challenges, state channels and things of that nature are kind of hard to do with hardware wallets. There's some interesting new approaches for that. And then, of course, we have to keep current. There's Taproot and Schnorr and all that. So,
Yeah, and then on top of that, there's new technologies that could probably be implemented into these standards you're building. One, I couldn't stop thinking about the cold card I know is working on, and Blue Wallet already has enabled to a certain extent as NFC capabilities. Is that something that excites you guys, or that you would stay away from a security perspective?
I have a mixed thing there. I think it is something that we're going to need to support. If I'm got 5, 10,000. I mean, it'd be different for everybody. Somebody in India will have a very different, number for that. The convenience of NFC is amazing. Still doesn't solve the multi-sig problem. It makes the single signature problem easier. Makes this back and forth that Wolf and I were just demonstrating easier. So yeah, let's do it for there. If that key on that NFC doesn't have total custody of your funds, it's just a participant in a larger multi-sig and the threat model against it, and you know exactly what it is, I might put more money on it. But if I'm trying to save money for my children and my grandchildren, and I am hodling for, and never plan to sell for a decade or more, no, I'm going to use something that doesn't use an NFC chip, which is, could be potentially supply chain compromised and other different things of that nature. So it's all about thinking about threats. And, we have a book free called Smart Custody. You go to smartcustody.com and download the old version. If you go to GitHub, you can see some new chapters that we're going to be adding to it for Smart Custody 2.0. But, how do we explain this to regular people is hard. So I wouldn't say we have a whole chapter on how do you do a threat model. And, my basic argument is, don't do this unless you've got a significant amount of money in of your net worth in Bitcoin. If you do, spend a couple of hours to do the exercise we have you walk through. But if we can figure out how to make that easier and avoid some of those things, create some common scenarios that everybody can use, help you understand how to make choices, whether or not you're a brand new user who, doesn't know how to make decisions, or whether or not, you're Avanti Bank, another one of our patrons, who is, potentially, storing billions of dollars worth of funds, as they grow. So, those are very different threat models. We want to be able to help make that easier.
No, thank you again for doing that, because it's imperative. And that's what I wonder as we're having the discussion. Do you think there needs to be pressure put on wallet developers from Bitcoin users to, I don't want to say get in line, but to work towards the standards that you guys are working towards? I guess to Steelman, what would a wallet provide?
If you use a wallet, if you use a wallet and you think that you've seen some technologies here, or you go to our YouTube channel, watch our technology overview, if you think your wallet ought to support these things, well, there's nothing stopping people. It's all open source. But if they feel like, well, this isn't quite right, there's something that is missing from this, or that we need to add, and we'd like to integrate with this, well, we're available to work with wallet developers to expand the technologies in the directions that benefit the whole community. And so that's what we're here for. And, so yeah, I mean, I would say, I wouldn't put it in terms of putting pressure on them, but, ask for what you want. And if more interoperability, more support for air gap standards, we're also working on Tor gap standards where communication takes place over the Tor, the Onion router network. For, even though it's connected through the internet, it's much more secure and much more private. So we're going to be doing projects that use that as well. We already have some. And these things are all about the resilience of the community and the privacy of the community. So if you want that, ask for it, and tell people that we exist and that that we can help.
Yeah, that's what I hope.
And we deserve the support, and it's, some of these companies are making, millions and millions of dollars, especially if we talk about the tier one wallets, say, hey, support these, these types of things, not just in your code, but you've got the money, support them financially, because, we want these standards to be around 10 years from now. If somebody basically says, gosh, there's this weird little trick you can do here that we didn't anticipate. We need to be able to fix it fast and deploy it to the whole ecosystem in the same way that we were able to do in the early days of SSL, when there were lots of people supporting TLS. But then after 15 years, it was down to 1/4 time of one person. We don't want to get to that point. We need to create a base that can last for decades.
Well, I'm happy you brought the TLS SSL experience up, Chris, because that's what I wanted to sort of end the conversation on. Like, what are the lessons learned from that open protocol project that you worked on for quite some time? Obviously, you've mentioned the fact that it's at the point where someone argue that it's completely neglected, which you don't want to see, especially if there's trillions of dollars of value flowing through it to a certain extent. What did you see during those projects that you want to avoid in Bitcoin at all cost? Is Bitcoin doing?
Well, we could probably do a whole podcast on that. Some of the early things are, I personally was shocked that so TLS 1.3, which came out in 2018, end of 2018, was almost 20 years after, if it had been out one more month later, it would have been 20 years after I finished TLS 1.0. I never thought it would take so long. And realistically, TLS 1.3 really was TLS 2.0 or SSL 4.0. I don't know. The numbers kind of get confusing after time. But there's no pressure to. There isn't sufficient pressure to upgrade. So something I've encouraged other standards. I'm one of the co-authors now of the decentralized identifier standard that W3C is getting close to finalizing on, and verifiable credentials and things of that nature, is things like expiration dates. So yeah, maybe somebody will use a cipher suite that is expired. But if some investor or somebody else comes along and says, "Hey, you just lost $1 billion of your stock value because you're supporting things that were expired," they can protect their wealth that way. So for irresponsible stuff. It's hard. I'm sure that Tim Dirks at Google, who was my co-author of TLS 1.0, would have a different position there. But I think that the arguments are sound that we can do better. Another element that I think is real interesting is, although decentralization as we know it today as a term of art in our industry, we would say that TLS is centralized, right? It depends on certificates. Certificates then depend on a root of trust. But you have to recognize, back then, we were trying to decentralize against a monopoly of Microsoft. A lot of what my job as a standards leader was to say, hey, Microsoft, you've got to not be one ring rule them all. You need to cooperate with the rest of us. And we were able to eventually force them to participate in the commons so that we could all work together. And that was a form of decentralization. But centralization always creeps back in. When SSL and TLS were first deployed, we thought, oh, well, there are lots of CAs, and there's nothing that stops the internet from having multiple DNS routes. A lot of these different types of things were allowed, for maybe not truly decentralized, but distributed choices. But then over time, VeriSign acquired a lot of the secondary CAs. Then ultimately the browser companies discovered, oh gosh, the users don't need to decide what CA to use. We're going to decide for them. And so centralization creeped back in. I believe that centralization can creep back into Bitcoin, Ethereum, into all of these different protocols, because I honestly do not believe there's such a thing as perfect decentralization. It may be, I can't prove it, but it may be impossible, because some parts of decentralization conflict with other rubrics of decentralization. So, we have to balance those. We have to be able to allow people to make some choices there, to be able to make good decisions in the future.
I think one of the ways we see centralization creeping into Bitcoin, correct me if I'm wrong, Christopher, is like the mining pools that become dominant and things like that. And so when they gain a certain amount of hashing power, they basically are a kind of centralized authority at that point. And so we try to, the community tries to balance that out. Does that sound right?
Yeah, but it's other things. I mean, so mining pools and obvious. We can, blockchain commons is not involved in kind of a lot of the mining conversations. For different reasons. It's not a place where we can make a difference. But, if we were all using, Ledger and Ledger clones, we would not have much innovation. And, when Ledger decided, I'm sorry, picking on Ledger, they have sponsored blockchain commons stuff in the past, but they're the biggest player out there. Over time, there can become incentives for Ledger to start throwing its weight around. Oh no, we don't want Taproot, or we don't want whatever the next latest thing is, and then it doesn't happen. And so that's another form of centrality, is lock-in, being locked into old choices. So we want to allow for innovation. But we have to be cautious, because, in the end, it's the consumer sometimes pays the price for innovation. So, like, one of the things when we were talking earlier about talking to your wallet vendors about supporting some of these different things, Blockchain Commons has limited resources. A couple of different engineers, number of volunteers, etc. So we have to prioritize things. I prioritize things when two wallet companies want it. So when somebody comes to me, as has happened recently, going, gosh, we've really got to solve this problem in the silicon level, where, we would like to have elliptic curve done on the chip rather than in code on a secondary, less secure chip. If I've got two companies that are interested in that problem, then that's something that sort of triggers, okay, let's maybe do some research on this. Let's, identify the use cases. Where are the low-hanging fruit? Who else might we partner with, or whatever. But the signal that I need is that two companies want it. So like with the PSBT, Kobo Vault, which no longer is actively supporting, they've been, another company's taken over their product, and Blue Wallet, basically, they ran fast and implemented our very first preliminary version of our PSBT stuff way before we expected it to. But that was a signal from the marketplace that interoperability was desirable, and so we put a lot more effort into PSBTs and finalizing it, and the versions that you see today are, because more than one company are involved.
Yeah, it's a fun space to play in. Big problems to solve. There's obviously on the wallet side too. There's, unfortunately, or for some reason or another, ego tends to pop into the conversation. And again, like, I think what you guys are working on is deeply underappreciated. And I think getting these standards out there as quickly as possible, because what we assume is going to happen in terms of Bitcoin adoption is going to continue to go up, is what I assume that we're assuming. You're going to have not only individuals getting Bitcoin, but people building on Bitcoin and being able to quickly create, not necessarily quickly, but create a standardization across certain processes that make it so people aren't just building on things that are never going to be able to be interacted with is massive. And it does seem like you guys aren't getting enough shine. And so, like, how can we, as a TFTC community, like, help you guys get more attention and more funding and more conversations going throughout the users
Well,
world?
one of the easiest ways is if you have a Bitcoin account, excuse me, a GitHub account, is support us through GitHub. They're a $20 a month patronage makes a difference for us. So we're at the point now where I can hire, a half an engineer FTEs off of our GitHub revenues. Obviously, we accept Bitcoin through BTC Pay. We've received grants from Human Rights Foundation and others. So, encourage these organizations to still do so. But also, you can volunteer. Let's say, one of my challenges, I'm the executive director and principal architect, which means I'm spending far too much time coordinating, trying to get grants, talking to different people, writing, various people, volunteer to be in, to work with us on these types of things. Or if you're a coder or a writer, help us, write better documentation. One of our very successful projects this year was to translate our Bitcoin course to Spanish and Portuguese. I would love to see an Italian version of the course. Some of our other material, even if you're not, kind of at the level of doing Bitcoin Core command line stuff, we have other documents that could be translated or be updated or made easier and more accessible to people. So there's a lot of volunteer opportunities as well.
Get on it, freaks. Doing very important work here. I guess before we wrap up here, is that we've been deep into the technical details of the project and what you guys have been working on within it, but what are your views for Bitcoin's future? Are you optimistic that it will succeed and continue to succeed? Do you think it's an imperative? How and why are you working on what you guys are doing outside of creating standards so other people can play nicely together?
Obviously, I like to, it's not really a brag because it's also kind of a shame because, the first Bitcoin ever purchased were for under 10 cents on Mt. Gox way back when. If I'd never sold any, I'd be set for life, but I did. So I actually lived off of Bitcoin for a year while working on a startup idea that didn't really take off. But what I have left, I'm holding on to. And I've always believed that the future of Bitcoin is bright. I deeply believe that it's a world-changing technology. And I'm really honored that Christopher asked me to work with him on Blockchain Commons because it's benefiting everybody in helping that technology change the world.
Yeah, for me, what I think probably one of the biggest things is obviously, I have some Bitcoin from my work at Blockstream and other stuff, but Blockchain Commons largely is a Bitcoin organization in that we pay everybody with Bitcoin. As much as possible, we don't want fiat. GitHub is easy and convenient for those people who want to do $20 a month or whatever. I would love to be able to have something like that for Bitcoin in the future. But because of that, the fact that Bitcoin's down right now or up or whatever, it has an impact on us, but not nearly as much. Basically, about as much Bitcoin went in this year as went out. So I consider, and we have new technologies and new capabilities. I figure that's a win. I don't care as much about the up and down. And I would say, when you can find an old video of me talking about introducing Bitcoin or whatever from 2015 or 2014, and I'm kind of going, oh, it's kind of stable right now at 30, and I'm just not thinking about Bitcoin in versus fiat. Bitcoin is Bitcoin. It's the way we're going to be transacting and interacting with people around the world. And at some point, obviously not this year, we may no longer even be referring to a fiat value. I will pay X Bitcoin an hour for the professional, cryptographic protocol engineering work that we do. So that's the future.
It's pretty bullish. I'm very excited to hear, because usually I have developers working on like the nitty gritty, and they're some of the most bearish people I've ever met, because they know how things like tech debt and trying to make all this interoperable. So I'm very happy to see that you guys are optimistic about the future of the protocol. And again, thank you for all the work that you guys do. It's underappreciated, and it's very high leverage in terms of making it so future Bitcoin users, not only Bitcoin users today, but some that haven't even been born yet, are able to leverage software that can work interoperably, which is imperative if you actually want to scale this thing to the masses.
Yeah. Well, thank you for having us. And, when we have the next major release of something, we'll be glad to demo it. Or if you've got some specific thing you want us to look at, let us know.
Yeah, no, I'd love to have you guys back on. If you're ever in Austin, please let me know. I'd love to meet up in person. You got to get out to a BitDevs meetup in Austin.
I've been to a couple, so we'll have to do it again.
Oh, hell yeah. All right. Where can we find you guys? Where can we find out more information about the Bitcoin Commons? Where should we point?
blockchaincommons.com is our main website. Obviously, we're a developer organization, so most of our work is on GitHub Blockchain Commons. And there's 6 links at the top that have our most important projects there. You can go to smartcustody.com to get the book, which I still think it's, if you're kind of a intro ledger class single sig user, still I think has the safest process for doing a single sig for Bitcoin cold storage. So that's a free book, smartcustody.com. And then if you want to, play around with lifehash.info. We didn't talk about TorGap, but we're also, very active in trying to figure out how to leverage those privacy technologies. So we have something called Spotbit. So spotbit.info is a decentralized, it's more distributed than decentralized. We want it to be decentralized price server for Bitcoin. So it basically looks at, 50 plus different price servers and volumes around the world, and allows you to either use our data, or it's an open source thing. You can go put it on a $5 VPS somewhere, and you can decide how you want to price Bitcoin versus around the world. Wolf?
And you can access it through Tor. Yeah. So,
it's completely private.
Right. So, yeah. So our Gordian Recovery tool that I'm working on now, which will also be an iPhone app, will use Spotbit to get prices. So you'll be able to, for example, report on the historical prices that you acquired Bitcoin at for your tax records, things like that, as well as recover and possibly even sweep accounts eventually. Although, again, it's an online tool, so it doesn't have to handle any private keys. You can have it, for example, you'll be able to put a BIP39 that you don't know what's on it. It'll find all the things that might be there on the account. It'll create a PSBT. You can send that over to Seed Tool for signing, send it back, and sweep that account to something else. So the idea is there's a very clear separation of interests. If you're doing a tax return or whatever, and you need, information for capital gains, you'll use Spotbit through Tor to get pricing on those things, so you can document your transactions. So, that's, again, very clear separation of concerns and upholding the Gordian principles at every step.
Yep.
Hell yeah. Freaks, if you're listening, go check all this out. We're going to link to as much of this as we can in the show notes. And just want to thank you again, Christopher and Wolf, for the work that you're doing, for coming on. Can't wait to do it again. Very excited to see what you guys produce going forward.
Thank you.
All right. That's all we got this week, freaks. Peace and love.